Hello students, I am Sanjay Shirude, teacher in mathematics from Willingdon College, Sangli. Today we are going to learn differentiation from mathematics paper 2 with the help of PowerPoint presentation. Now we are going to see the meaning of rate of change, then definition of a derivative and the formula associated with it, derivatives of some standard functions, and also relationship between continuity and differentiability. Now, derivatives by method of first principle. We know f dash x equal to limit x tends to 0 of f of x plus h minus f of x upon h. Now, this is the formula for derivatives from first principle. Now we consider a simple example. Let us consider a function f of x equal to e raised to x. Now we have to find f dash x. Here we use this formula. F dash x equal to limit h tends to 0 of f of x plus h minus f of x upon h. Now in this formula we want f of x plus h. Now here in given function we replace x by h. So we get e to the power x plus h. Now we substitute the values here and we get limit h tends to 0 of e raised to x plus h minus e raised to x upon h. Now we can simplify this. Limit h tends to 0 of e raised to x into e raised to h minus e raised to x upon h. Now this here limit h tends to 0 of, here e raised to x is common, in bracket you write e raised to h minus 1 upon h. Now here variable is h. So here e raised to x is a constant, can be taken out and we get e raised to x into limit h tends to 0 of e raised to h minus 1 upon h, and now this is our standard formula. Here you write e raised to x into 1. Limit of e raised to h minus 1 upon h as h tends to 0 is 1. So finally we get the answer is e raised to x. So you say that derivative of e raised to x is e raised to x. Now we can find, now we will continue rules of differentiation. Here d by dx of u plus or minus v is equal to du by dx plus or minus dv by dx. That means derivative of sum of or a difference of two functions equal to sum or difference of the derivatives. Now here derivative of product of two functions equal to, see here first function is u, second is v, and now we can remember this rule as u into derivative of v with respect to x plus v into derivative of u with respect to x. Now our next formula is derivative of k into u, where k is real number, that is constant. So the derivative of k into u is k into derivative of u with respect to x. Here constant can be taken out from the derivative. Remember this thing. And now our last formula is, that is a quotient rule, d by dx of u upon v, that is equal to v into derivative of u minus u into derivative of v upon v square. Here we provide this v square is not equal to 0 because it is denominator, and if it is 0 then we can't define. Now here we are going to see derivatives of some standard functions. Here By using derivatives from first principle, we can find the derivative of these standard functions. Here first function is c. Now it is a constant, and you know very well derivative of constant is 0. Now we consider the next function, that is x raised to n. Now its derivative, that is d by dx of x raised to n, is equal to n into x raised to n minus 1. Now here the power becomes multiple and we reduce the power by 1. Similarly, we consider the next function, that is 1 upon x. Now its derivative is given by minus 1 upon x square. Now in general, derivative of 1 upon x raised to n is given by minus n upon x to the power n plus 1. Students, these are standard formulae. We learn in 11th standard already. Now, the function is root x. Now its derivative is given by 1 upon 2 root x. Here function is sin x. Then we say that its derivative is cos x. And if function is cos x, then its derivative is minus sin x. Now, we consider remaining functions. Here derivative of tan x is a sec square x. Derivative of sec x is a sec x tan x. Similarly, derivative of cosec x is a minus cosec x cot x. Now the function is cot x, then its derivative is minus cosec square x. Now students, these two and these remaining four are trigonometric functions. Now you can remember their derivatives as, see here, a short trick or key point. When a function starts from c, like a cos x, cosec x and cot x, their derivative starts from negative sign. Remember this thing. Now, our function is e raised to x. Now, by using from first principle, we find already its derivative is e raised to x. Now, instead of a raised to x, you consider a raised to x. And its derivative is a raised to x into log a. If the function is log x, then its derivative is 1 upon x. Similarly, the function is log x to the base a. Then what is the derivative? Then you say that 1 upon x into log a. Here the base is e and here base is a. By using change of base formula, you can write this log x to the base e upon log a to the base e. Then you can find its derivative is 1 upon x into log a. Now, derivatives of some standard functions, then we consider derivatives of composite functions. Now, what is the meaning of composite functions? That is, function of another function. Now, see here, we consider the theorem. If y is a function of u, is a differentiable function. The meaning of a differentiable means derivable function. That means this derivative is exist and finite. So here y is a function of u and u is a function of x. That means u equal to g of x. Such that the composite function y equal to f of g of x is a differentiable function of x. Then what we say? Dy by dx equal to dy by du into du by dx. Now this is very important formula for us. Now we see the proof. What is the given thing? Here we are given that y equal to f of u and u equal to g of x. We assume that u is not a constant function. If it is constant, then its derivative becomes 0. So we say that we assume that u is not a constant function. Let there be a small increment in the value of x. Say delta x. You may write in this way also. Let a delta x be the small increment in x, or let a delta x be the small change in x. Now, after that you say that then delta u and delta y are the corresponding increments, corresponding changes in u and y respectively. Now this is very important statement. Now our next statement is, as a delta x, delta u, delta y are small increments or small changes in x, u and y respectively, such that delta x not equal to 0 and delta u not equal to 0. Also delta y is not equal to 0. Then we consider this incremental ratio. Why we say this is incremental ratio? Because delta x, delta u and delta y, these are increments. So their ratio is known as incremental ratio. And now we consider delta y by delta x equal to delta y upon delta u into delta u by delta x. Now you can remember. Now we are going to prove dy by dx equal to this. Now simply here you have to replace d by delta here. See here. D by delta. So we get delta y by delta x equal to this. Now this is known as incremental ratio. Now we consider the previous step as it is. And now by taking the limit as a delta x tends to 0 on both the sides, what we get? By taking limit of both sides we get this. Limit of left hand side as delta x tends to 0. That is equal to limit of right hand side as a delta x tends to 0. Now limit of right hand side as delta x tends to 0 means limit of first function into limit of second function. And now our next step is as a delta x tends to 0. We write a delta u tends to 0 because u is a continuous function of x. So you say that delta u also tends to 0 as the delta x tends to 0. Now, here we write now, instead of delta x, we write here delta u tends to 0. Remaining both the terms are same. Both the terms remains the same. Here we change only delta x by delta u. Why we write here? Because we know that the definition of a derivative, that is Leibniz notation. Limit of delta u by delta x as delta x tends to 0, that is du by dx. Similarly here denominator is delta u. So here we want delta u tends to 0 and we are given already as delta x tends to 0, then you say that delta u tends to 0. So we replace here delta x by delta u. Now we say this is equation number 1. Now here, since y is a differentiable function of u and u is a differentiable function of x, then we have limit delta y upon delta u as delta u tends to 0, that is the first term of right hand side of equation 1. That becomes dy by du and this second term becomes du by dx. By using definition of derivative, that is also known as by using Leibniz notation. Now here you say that this is dy by du, this is du by dx, then equation 1 becomes this is equal to dy by du into du by dx. Now from 1 and 2 we write, see here, limit delta y upon delta x as delta x tends to 0 equal to dy by du into du by dx. We say equation number 3. Now, in equation 3, the right hand side is exist and finite. That implies left hand side is also exist and finite. And therefore, left hand side is equal to dy by dx. Again you say that the reason, that is by using the definition of a derivative or Leibniz notation. Now here you say that this is your left hand side of equation 3 and that is equal to dy by dx. Then put this value of this left hand side of equation 3 here, that is dy by dx. Then what we get? See here, equation 3 becomes dy by dx equal to dy by du into du by dx. Now this is our target. Now this proves the result. And now it is also known as chain rule. Now remember this word. It is known as chain rule and it is very, very important for us to solve our examples from our given exercise. Now, Derivatives of composite function, here we continued. Here, in another words, if y equal to f of u is a differential function of u, and u equal to g of x is a differential function of x, such that the composite function y equal to f of g of x is defined, then dy by dx equal to f dash of g of x into g dash of x. Now we use this definition to solve our examples from our exercise. Now remember also this definition, dy by dx equal to f dash of g of x into g dash x. Now see the note. If y is a differential function of u1, then ui is a differentiable function of ui plus 1 for I equal to 1, 2, 3 and so on. The last term is n minus 1. Now see here, if you put here I equal to 1, then what we get? u1 is a differential function of u1 plus 1, I equal to 1 here. So it becomes 2. So u1 is a differential function of u2. Then if you put I equal to 2, then we will get u2 is a differential function of u3 and so on. Now, then you say that dy by dx equal to dy by du1 into du1 by du2 and so on. Means derivative of y with respect to u1, derivative of u1 with respect to u2, derivative of u2 with respect to u3, and the last term is derivative of un with respect to x. Now we write the previous term. See here. Here we write 2. In previous term we write 1. In previous term and so on. What is our next term? du3 by du4. So here we reduce n by 1. Simple thing. So you write this and so on. See, this is also known as chain rule. This is also important. Now here we consider the n functions. u1 is a differential function of u2. u2 is a differential function of u2 and so on. And so we remember this also. And now we change this rule in terms of 3 variables only. See here, for example, if n equal to 3. Now this is very important, students. That is, if y equal to f of u1 is a differentiable function of u1 and u1 equal to g of u2. That is also a differential function of u2. That means its a derivative is exist. And u2 equal to h of u3 is a differentiable function of u3, and then we say that dy by dx equal to, see here, y is a function of u1, u1 is a function of u2, u2 is a function of u3, and u3 is a function of x. Then you say that dy by dx equal to dy by du1 into du1 by du2 into du2 by du3. This is also known as chain rule for 3 variables. Now remember this formula also. This is very, very important. Now, we are going to see derivatives of some standard composite functions. Now see here. Now, already we see this is a formula. Derivative of constant is 0, derivative of x raised to n is n into x raised to n minus 1 in 11th standard. Now, instead of x, now standard function is in x, like x raised to n, 1 upon x, sin x, cos x, root x. Now, instead of x, we consider f of x. See here, f of x raised to n. Instead of x, you consider f of x. And now it can be written as, see here, n into x raised to n minus 1, x replaced by f of x. So we get this n into f of x raised to n minus 1. And now here you consider instead of x, f of x. Therefore multiplying this answer by derivative of f of x, that is f dash x. Now this is by using chain rule. Now similarly, here you know derivative of root x is 1 upon 2 root x. Instead of x we consider f of x. And so root of fx, its a derivative is given by, see here, 1 upon 2 root fx into f dash x. So you write in this way, f dash x upon 2 root fx. Now, here you know the formula for x raised to n here, that is n into x raised to n minus 1. Power becomes multiple and we reduce the power by 1. Same thing is here. Now, see here, derivative of 1 upon x raised to n minus n upon x raised to n plus 1. Same thing is here. Now you write here minus n into f dash x upon f of x to the power n plus 1 by using this formula, and by using this formula we write this derivative of f of x raised to n. Now we consider derivative of sin x, that is cos x. Now here derivative of sin of fx, that is cos of fx, into derivative of fx, that is f dash x. Same thing is here, derivative of cos x is minus sin x, so derivative of cos of fx is minus sin of f of x into derivative of fx is f dash x. And now here you see derivative of tan of fx, that is sec square of fx into f dash x, because you know that derivative of tan x is sec square x. See here. Now we consider remaining functions. Now we write directly derivative of sec of fx. You know derivative of sec x is sec x tan x. So you write instead of x, f of x here. So sec of fx into tan of fx into f dash x. Very simple thing. Now derivative of cosec of f of x, that is minus cosec of f of x into cot of f of x into f dash x. Students, now you can tell me derivative of cot of fx is minus cosec square of fx, because you know derivative of cot x is minus cosec square x. So instead of x, we write f of x and multiplying it by its derivative, that is f dash x, by using chain rule. Now you know very well derivative of e raised to x is e raised to x. So derivative of e to the power f of x is again e to the power f of x into its derivative, that is f dash x. Now remember all these are formulae which are very, very important for us. Now same thing is here. Here replace a by e by a. So you write here in this way. And now you know very well derivative of a to the power x is a to the power x into log a. Instead of x, you write f of x, and so we will get this formula. Here we multiplying by the derivative of f of x. Now derivative of log x is 1 upon x, so derivative of log of fx is equal to f dash x upon fx. And same thing is here. You may write this in this way, log of fx upon log a to the base e by using change of base formula, and then you write this answer. Now these are very important formulae. Here we write derivative of some standard composite functions. Now we are going to see examples on composite functions. Here our question is find dy by dx. Example number 1, y equal to under root x cube plus 7. Now differentiate this with respect to x, means differentiate both the sides with respect to x. So what we get? Dy by dx equal to d by dx of under root x cube plus 7. Now here we consider this is u. See here, let u equal to x cube plus 7. Then y becomes root u. This is y. It becomes root u. Now using chain rule, here you have to write, see here, dy by dx equal to dy by du into du by dx. Now here we consider derivative of y with respect to u. What is this? Derivative of y with respect to u. Derivative of root u, that is 1 upon 2 root u. Variable is u. So you write in this way. Now into du by dx. What is u here? That is x cube plus 7. Its derivative is derivative of x cube plus 7. That is d by dx of x cube plus 7. Now it becomes derivative of x cube, that is first term, plus d by dx of 7. Now 7 is constant, so its derivative is 0. And derivative of x cube is 3x square. And now if you put the value of u, that is x cube plus 7, then we get the final answer. Here our final answer is, see here. Now I show you next step, dy by du. We find here 1 upon 2 root u. and du by dx equal to 3x square because derivative of constant is 0. So derivative of 7 is 0. And now if you put these two values in this formula, that is the chain rule, so we get this. And now after simplification, we write dy by dx equal to 3x square upon 2 into under root x cube plus 7. Now this is our answer. Now to see our next example, y equal to under root 10 of root x. Now students, see here, by taking derivative of both the sides with respect to x, we write dy by dx equal to d by dx of right hand side. Now here we consider y equal to root u. Now this is u. बघूया बरं काय होत आहे. Now u equal to tan of root x. Here you say that u equal to tan v because u equal to tan of root x. So you write tan v. What is v now? That is root x. So you write where v equal to root x. Now by using chain rule, see here, dy by dx equal to dy by du into du by dv into dv by dx, because y is a function of u is a function of v is a function of x. So you write by using chain rule this. And now we have to substitute the derivatives of these three, y, u and v. See here, dy by dx equal to, what is dy by du? This is y equal to root x. You know y equal to root x, then you say that its a derivative is 1 upon 2 root x. Instead of x you write this, so 1 upon 2 root u, but u equal to tan of root x. So I write it directly. And now u equal to tan v, its a derivative is sec square v, but what is v? That is root x. So you write directly. And the derivative of root x is 1 upon 2 root x. Now we can simplify this. See here, 2 into 2, that is 4. Here I write that. Now sec square root x as it is. Sec square root x as it is. Now here the value of y, you see here root u, that is root tan of root x. So this becomes a y. Okay. And now this root x as it is. So after simplification, this is our answer. D by dx of given function, that is under root tan of root x, is equal to this. Now to see next example, you have to do this example as a homework. I will give you some important information or some steps here. See here, our first step is by taking derivative of both sides. So you write dy by dx equal to d by dx of this. Now see here, derivative of first term plus second term, that is derivative of u plus v. So you write derivative of first term plus derivative of second term. After this you write, see here, derivative of x raised to n is n into x raised to n minus 1. D by dx of x raised to n is n into x raised to n minus 1. So you write this in this way. Derivative of bracket cube, that is 3 times bracket square. 3 times bracket square. And now instead of x, we write bracket. So its derivative is here. Derivative of x square is 2x. Derivative of 4x is 4. And so on. Similarly, we write here the same thing. Now we will see. This is the derivative of second term. Now, after simplification, this is our final answer. Now, we will stop here and we will continue in the next session. Now, students, we will stop here and we will continue in next lecture. Thank you.